Hi, this is a vodcast about some basic stuff about triangles. A lot of this you probably know already, but I just want to make sure everybody's on the same page. So um, first, I want to talk about uh, something besides a triangle, which is a more general term called the polygon. And a polygon, you may have heard of this before, is, and this, you might not have seen this definition, but it's a closed figure whose sides are segments that intersect at their endpoints. So here are some polygons. Like this would be a pentagon, right? It's closed. Here is a quadrilateral of some sort. So it could also be a pentagon. I mean, a polygon could have sides like this. You know, could go all kinds of which ways like this. Anyway, so polygons are like that. Well, you know that already, hopefully. Triangles are three-sided polygons. So I start with three sides. You already know this also. So there is your typical triangle. And I'm going to make it so I can actually see move this thing around a little bit. So, so kind of like in Sketchpad, we can move this triangle around. That's nice. And we usually name triangles with letters that are the names of the points that are the vertices. So we have three vertices, and they're the vertices of the angles. So we name this triangle with a symbol that looks like a triangle and three letters that are the vertices of the triangle. So that would be triangle ABC. Somebody else might come along and call that triangle CAB, same triangle. Okay, we also name the angles in the triangle. The angles in this triangle, I could use three letters, angle BAC, would name that angle, and I could name angle ABC, and that would be this angle over here, and angle BCA. So this is just the same way with naming angles. However, in this case, you could also just use a single letter, and here's the rule. If a single letter, you name an angle and it's not confusing in any way, like in this picture, angle A is clear what I mean by angle A and what I mean by angle B, then you're allowed to use one letter to name the angle. So those are the same thing. But if I have a picture like this, or I have a triangle and there's more than one angle at this vertex down here, let's call it D, and this is E, and this is F. I can still call it, and this is G. I can still name angle G and angle F, but I can't say angle D. I have to distinguish angle GDE. So angle GDE is this angle that's not in the triangle, and then there's angle GDF. GDF that is inside the triangle. So that's the rule. Okay, so the other thing I want to talk about are classifying triangles in different ways. Oh, the other thing I should say on this page is we also have sides. Talked about the angles, and the sides are segments. Segment AB, segment BC, segment AC. Those are the sides of this triangle. Bet you knew that already. Here, so we have two ways of classifying triangles. One is by the angles, and the other is by their sides. So I want to demonstrate that. So I'm going to talk about some of these different kinds of triangles. An acute triangle, this is classifying by angles. Let me make a triangle here again. And let me show the vertices. I can actually show the vertices, and in this I can actually show the measurements. So, an acute triangle is a triangle with 3 acute angles, and all those 3 angles are all less than 90. So that is an example of an acute triangle. Let's copy that triangle, move it down here so I can fiddle around with it. Let's look at another kind of classification. Well, an obtuse triangle. Obtuse triangle is one that has one obtuse angle. So if I move this, just like we do in Sketchpad, now that's an obtuse triangle because one of the angle is obtuse. What about the other 2 angles? Well, you can only have one obtuse angle in a triangle because, as we learned in the Sketchpad exploration, the angles have to add up to 180, and if one of them is bigger than 90, then the other 2 have to be less than 90. That's just a fact of addition and subtraction. So we have those triangles, and then where you already know what a right triangle is, I'm sure, but a right triangle has one right angle. So let's see if we can turn this thing into a right triangle. Oh, I can get it close. I can get it very close, but not, I can't let go and just get it right on. So that's about as close as I can get that. That's close to a right angle. I could make it exactly a right angle by putting that little mark in there. Maybe hiding the angles so you don't know that it's really not exactly 90 degrees, but if I do it like that, now you know it's exactly 90 degrees because I'm telling you with that symbol. Okay, so that's how you classify triangles by angles. Acute triangle, obtuse is all 3 are acute. Obtuse is 1 obtuse, the other 2 are acute, and a right triangle with 1 right angle and 2 acute angles, which in fact the other 2 acute angles happen to be complementary angles with each other. Okay, back up here when now we're talking about sides. You're probably familiar with an equilateral triangle. I'm going to do a little bit different drawing tool here to find an equilateral triangle. I think there's one in here that I can make. Here's an equilateral. There we go. This one, I can get as many equilateral triangles as I want, but here's one. So this triangle has 3 congruent sides, and we would show that by marking it like this. 3 congruent sides. There's another kind of triangle that it's called a scalene triangle with no congruent sides. Let me grab this one. That looks like it might be a candidate. I think I'll hide the angle measures and show the side lengths. Okay, so this is showing that one side is 3.6, one side is 6.2, one side is 7.5. None of those are equal, so it's scalene. The last classification by sides is called isosceles, a triangle with at least 2 congruent sides. So I think I also have a drawing tool up here that makes nice isosceles triangles. These can be long, they can be tall and skinny, they can be short and flat, but they have 2 congruent sides. So I would show that. By the way, I could show that this is isosceles in my drawing by making different marks on all 3 sides. That tells you that no 3 sides are congruent, as far as we know. We can't assume otherwise. An isosceles triangle has 2 congruent sides, and I'd mark it like that. Here's a question for you. Is an equilateral triangle isosceles? Well, does it have 2 congruent sides? Yes, it has 3 congruent sides, so it is also isosceles. So if you're trying to say all the things that's true about an equilateral triangle, you would want to say it's both equilateral and isosceles. There's one more classification I have down here at the bottom, which is equiangular. So this is another triangle that has all the angles are equal. You might already know something about this too. Some of you have probably studied this before. But think about this. If all the sides are, or if all the angles are congruent, which I would show like this, be equal angular, I can maybe make these marks. Well, if we know that the angles all add up to 180 degrees, then what does each angle equal? I'm going to let you figure that out. Okay. I think that's about all we need to talk about. We'll have another vodcast with more vocabulary tomorrow. Okay.